Welcome to the PrimateCast.
Hey, everyone.
Today we'll have an interview with Dr. Heidi Lyn, who's an assistant professor at the University of Southern Mississipi, where she studies animal cognition in a very broad, comparative way.
Yeah, and we were lucky enough to sit down with her in early March when she came through Japan for a conference on the evolution of language that was held in Kyoto. And she had known about the PRI and the research that's going on here, so she took the opportunity to come down, and we're happy she did.
Indeed.
So, welcome to the podcast, Heidi Lyn.
Thank you very much. Thanks for having me.
So you have a history of working with bonobos, and I also saw from your CV that you also worked with marine mammals.
Yes.
So that's an interesting history.
Yeah, actually, I started with marine mammals, and then I started as a linguist back in the day.
Really?
And language was really very interesting to me.
I also saw you at UPenn. I also went to UPenn.
Did you?
Yeah.
At the same time or a different time?
I graduated in 2006.
Okay, so way after me.
Yes, he's still a youngin'.
But I did take linguistics there.
Okay.
Mark Lieberman, is he there?
Oh, yeah,
Okay.
Absolutely. So, yeah, I started as a linguist and had heard about the Washoe project with a sign language using chimpanzees, and I thought that was the coolest thing ever. But they pretty much shut it down and said, oh, but, they found out that it was really just her imitating, and there's really nothing else we could learn about that. And my mother took me to Hawaii for my sister's graduation present. It's a very long story. We won't go into it. But they sent me to Lou Herman's lab to visit after they found out what I was interested in. And I said, I have got to work here. So I came back and worked with Lou Herman's lab for 4 years.
So can you tell us about that lab? Like, what exactly does it involve?
Lou Herman's lab was a lab with 4 dolphins on the beach in Honolulu, that literally you'd stand on the tower looking at the dolphins and looking at Diamond Head and the beaches.
Paradise.
It was fantastic. There's nothing better than that. And he had trained his dolphins to understand gestural and acoustic signals so that they could actually recombine different symbols that meant ball or hoop or fetch or jump over or swim under. And he actually showed some understanding of word order or symbol order in those dolphins.
Oh, great.
So I came and I was watching them do that, and I was like, that is the coolest thing I've ever seen. I have got to come here. When I came there, they gave a series of lectures, and they talked about the work that Sue Savage-Rumbaugh was doing with Kanzi and the bonobos, and that just completely blew my mind because, of course, at Penn, they basically said, well, there's nothing interesting going on with animals and artificial communication, but clearly there was a ton still going on. Mm-hmm. And the fact that Kanzi and Pamanisha could understand English at the level of a 2.5-year-old child, and that they could actually utilize their keyboards in, really symbolic ways, it was just amazing to me. So I made my plan. I was going to go to Lou Herman's lab for, a number of years, and then I was going to go, and I was going to work with Sue Savage-Rumbaugh, and that's what I did.
Oh, that's great.
So now, actually, even PRI has been involved in some projects, but we hear a lot about this, the parallels between, for example, cetaceans and primates in a lot of aspects of social behavior and also cognition. But this is also going back a number of years. So,
yeah, I did a paper recently, actually looking not really specifically at these artificial language systems. And in dolphins, what's been interesting about the language-like systems that they've created with dolphins is that they were all one way. So there was Lou Herman's, which was focused on comprehension. So humans would make the signals, and the dolphins would have to follow them. And then Diana Reese had created a keyboard system where the dolphins could come and press the keys on the keyboards, and a whistle would play, and then they would get whatever it was that was associated with the key that they pressed. So they had production on one side and comprehension on the other. And then I took the Language Research Center, which had both comprehension and production. But I showed it all the parallels that we saw just in those artificial language systems. So like acquisition of symbols, which was really, really fast for both of them afterward. They started combining signals. They would press the key, a whistle would play, and it was a whistle that they hadn't heard in their repertoire up to that point.
Was this like a keyboard?
It would be in the water.
In the water?
Yeah.
Underwater keyboard.
Underwater keyboard, and then they would just push, and it was a mechanical press on a button.
A bunch of buttons.
Yeah.
Are they big or how
They were pretty big. They're about 4 inches, or,
And they have lexicograms on them?
They were just really simple symbols at that point. There was just like a ring or an X or something. They didn't get very far. The dolphins were pretty young, but they only went for about 4 years. I want to say that whole project was only 4 years long.
Okay.
But what started happening was that the dolphins would whistle the whistle as they approached the keyboard. So they would whistle the ball whistle, then they'd push the button, and then they would whistle the ball whistle. Okay. And then they started seeing that they were hear the ball whistle while one of the dolphins was playing with the ball in the pool. Mm-hmm. And then what they started seeing was this ball and ring whistle combination where they had sort of mashed them together. And the keyboard didn't allow that. There was a half a second pause. So even if you pushed a button really quick, there was a break between them. Okay. But they had actually sort of combined them completely into one whistle.
That's cool.
And that only showed up at a time when they started playing with both the ball and the ring in their mouth at the same time.
Oh, wow.
So there was some really amazing stuff going on. One side or the other. The combination stuff is amazing in Lou Herman's work. And we saw a lot of the same kind of stuff in the apes. And the ape work was actually more complex only because it's such a longer period of time that those apes had been working, and the fact that they have so many abilities that are similar to humans so that we could actually see them a lot easier. So, I mean, just the fact that they can understand English, any English at all, but they can understand pretty complex English sentences is pretty amazing.
So the chimps and bonobos have been shown to understand a lot of components of language, like verbs, like give me or play. Mm-hmm. So how about the dolphins? Can they?
They did, yeah. So what the dolphins had about 10 different objects, and they had 6 different actions, I want to say, and then they had different modifiers.
Oh, I see.
So they could actually do things like right hoop, left ball fetch. So they actually used 2 different syntaxes too. Phoenix had an acoustic system, Achaicomai had a gestural system. And they would, Achai's system said indirect object, direct object, action. So what they would say, if they said hoop, ball, fetch, it meant take the ball to the hoop. Mm-hmm. And so she would have to reorganize things in her brain a little bit.
That's interesting.
But they could do up to 5 symbol sequences, basically. Left hoop, right ball, fetch, and stuff like that.
Oh, wow.
And she could get it.
That's cool.
It was very cool. Actually, here's my favorite story. They also created a question system where they had 2 paddles. One was glossed as yes and one was glossed as no. And they would put a bunch of objects in the pool, and they would ask her ball yes, or ball question, which means is there a ball in the pool? And she would answer yes or no, whether there was a ball in the pool. So once they asked her to take a ball to a basket, and the basket was not in the pool. And they were like, what'll she do? And she went and she grabbed the ball, and she took it to the no paddle. Like, that is super cool. So they tested her again on that kind of stuff, and she would do that. She'd start combining things, like they'd tell her to jump over something that wasn't there, and she'd jump over the no paddle and stuff like that. So
very cool, very inventive.
Yes, very, very creative. Creative, that girl.
So by the time you went to the laboratory with Kanzi and Pan-Benicia, you already had some experience with.
Yeah, I'd already been there for almost research. 4 years, actually.
Okay, that's great. And what was your focus when you were studying Kanzi and Pan-Benicia?
For Kanzi and Pan-Benicia, I had a master's thesis, which was on fast mapping, which was bringing in new objects and seeing how fast they could learn English words. And they could, Kanzi in particular was very good at that task, and he passed on his first test half the time. So
that's great.
Really fast. My dissertation project was on vocabulary errors, and what I was trying to look at was the fact that when we would ask them, they'd have their entire keyboard in front of them, and just to pass the time, sometimes we would ask them to find things on their keyboards. And the errors that they made were clearly non-random. So we would ask them to find lemons, and they would touch lemonade or something like that, where we were like, okay, we can clearly see where they got that error from. They're just not randomly pointing to stuff. So I actually went back and gathered all of their vocabulary test data for a 10-year period and put it all together and started coding it. And it became really intense because there was a lot of codes you could do. Was it auditorily similar in the English language? Were the lexicograms similar? Did they look similar? Were they functionally related? But what we showed was that, in contrast to this idea of their understanding of their lexicograms being associative, you would expect them then to confuse lexicograms with lexicograms that looked like each other more often. Sure. But actually what you found was that the majority of their errors were categorically related.
Okay.
And they were also sort of hierarchically categorically related. So you could see them making errors within objects, but then within foods, and then within certain kinds of foods, like desserts were more likely to be confused with desserts, fruits with fruits, etc. Stuff like that.
And I saw you had a paper out recently about it was cool. It compares chimps, one chimp, and bonobos and children. So
yes.
And about declarative.
Yeah. So there's been a lot of talk about declarations and requests, and the idea that these language-using apes only use it to request items or ask for something. And that what's different is that humans use it mainly to share information. That's not actually about acquiring anything. So what I went back, again, I have actually an utterance database of over 100,000 uses of the keyboard by all of the chimps.
Wow.
And we combined it with some diary work that had been done with young children in the one-word stage. And so we took the kids' data, and we had the 3 apes' data, and we started looking at declaratives, and just pulling out the declaratives and looking at the types of declaratives. And now what we saw is that apes do make a lot fewer declaratives than the children do. It's hard to tell exactly why that is, though, because apes are in captivity. They have to ask for everything. It's a bit harder. But they certainly make a lot of declaratives, and they make the same kinds of declaratives as kids do. There were only 1 or 2 examples of declarative types that we saw in kids, and we didn't see in apes.
Can you give us some of those examples?
Sure. Well, the most obvious one actually is that kids do a lot of showing. They'll pick something up and they'll say, plane, and they just want you to look at it. They don't want you to touch it. They don't want you to take it. They don't want anything about it. They just want to show it to you. And we only saw that once in an ape, where they actually were just showing something. And then attention getting, like mom. They didn't do that either. Like if they wanted your attention, they'd walk over and touch you. So we didn't see uses of the keyboard for that purpose. But most of the other types we saw, including things like talking about things that had happened in the past, or talking about plans that they were making in the future. So really they would be in a car going someplace, and they would on the keyboard they would say where they were going, or they'd pass a place where they had seen a squashed turtle the day before, and they say turtle at the keyboard, stuff like that. So a lot of really interesting uses of declaratives, and the upshot was that while there may be something to this idea that humans do a lot more sharing than other species do, obviously other species still do have that capability, and it doesn't seem to be a biological difference between us and them, but possibly an environmental one.
So to that regard then, in nature, for example, where would you see the use of these types of declaratives between individuals?
It's a good question, right? I mean, why do the only time you would see anything that even remotely resembles a declarative is an alarm call. And alarm calls there's a lot of discussion about how symbolic they really are, how referential they really are, and there is an audience effect in most cases. So, for example, vervet monkeys won't necessarily make an alarm call if there aren't other vervet monkeys around to hear them. It actually is not to their advantage to do so. But how much do they understand about those alarm calls is a different question. So most of the time, when you're in a more natural situation in the woods and you're competing with other members of your own species, there's not a huge amount of cooperation that goes on. Now, the other time I can think of that it might be useful, at least for chimpanzees, to share information is when they're cooperatively hunting. So if they're actually trying to get each other's attention to, explain where to go or what to do. I'm not sure that happens. But
So I have a question about, I'm fascinated by the chimpanzee and the ape language projects. I like to read all about them. And I wonder if, as someone that's actually worked on one, it seems to me like there's a component of the project which has to do with always being surprised by interesting things that the subjects are doing, but they're not being that data is not being gathered in a systematic way, so it just serves as anecdotes, and then you have your separate research program. And I wonder, is it frustrating if you see them do these amazing things, but you know that you don't have a way of proving it because they only do it once? Yes. Like you said about the turtle on the side of the road.
It's so extraordinarily frustrating. And to try and come up with... Part of the problem is when you try to create experiments around some of these anecdotes. There's a fantastic anecdote, actually, one of my favorites of all time. And Kanzi and Pamanitia are in a play yard area, and they have visitors, so they're interacting with these new people who have come in, and they are given juice, and they don't normally get juice at that point in time anyway. And Kanzi puts down his juice to interact with the visitor and turns his back, and Pamanitia sort of walks behind him, pours half of his juice into her cup, and then puts his cup down and walks away. I was like, oh my God, that is amazing. Like, first, the deception. Second of all, to realize that he is going to, like, if you take all of his juice, he's clearly going to know this. You only take half of his juice. It was just amazing. And I kept trying to rack my brains to come up with a good way to test for that kind of deception. But once you sort of artificially create those situations, a lot of these apes, especially the language competent apes, are looking for what trick is up your sleeve.
Right,
and they're really just trying to figure out what the heck it's demand characteristics to the nth degree, and they're just trying to figure out what it is they're supposed to do.
Yeah, and so I have some similar things that have happened here. For example, when camera crews come, the chimps do a lot better at their tasks.
That's great.
Because there must be some kind of audience effect there. They know what cameras are. Yeah. And we have our video cameras, which have the screen on them. You can flip it around, they can see that they're on it. So they must have some idea of what a camera is.
I don't know. I don't even know if that's it, though, because a Keakamai in Hawaii used to do, like, her jumps were twice as high, and she just did things with so much more energy when there's a camera crew around. And I don't know if it was the camera itself or the extra people, or she sensed the excitement was going on. Or
so all of these things would be interesting from an audience effect type of study perspective to study. But if you brought in camera crews like enough times to do a study, then maybe they would be habituated.
Entirely possible.
It seems like a problem for these interesting anecdotes.
I did start, actually, I'm trying to do, my big problem has been declarative production. So I'm really interested in this whole idea of obviously they can declaratively point as well as everything else. And I tried to do this experimentally because I have all of the utterance data, I can pull it out there, but a lot of people do feel like that's more anecdotal, even though it's 100,000 anecdotes. But we created this similar situation to what they do with kids, and we had things happening behind us that the chimpanzees or the bonobos, that in this case, were actually supposed to then point to us, and we got several good examples of them pointing these things out. But again, we were trying to do it too quickly, so there were 5 or 6 things happening in one day, and they just stopped pointing, and they're just like, oh yeah, you guys are being crazy again, there's stuff going on behind you, whatever. Right. Or they were across the very, very large cage, and they were pointing like here in front of their bodies, and so you can't actually see that on video at all. So I have one example that is clear on video that I could actually show of a declarative point. Okay. So what I actually thought was, maybe what I need to do instead of getting the data and then writing up the paper is look at this as a much more long-term project. So with take me down to 4 bonobos, and every time I go up, I try to collect one trial on one of them, and then in 10 years, I'll have enough for paper.
That's great.
But for that kind of stuff, it might be that's sort of the way we have to start thinking about it now, and can't, because you just can't get enough of those interesting things happening at once.
Or if you try and do it systematically in a short time, then it loses. It loses everything.
Exactly. And the spontaneity is all gone too.
That's the hard part of studying spontaneous behavior.
Exactly.
Okay, so can you tell us about your current research?
Oh, what am I doing currently? I don't even remember anymore. Actually, I have a spatial memory project that I'm doing with more than just great apes. Here's what happened. On the campus that I work, they actually have bush babies, and they don't have any other primates. So I went up and tried to run the primate cognition test battery. I had run this with the enculturated apes and the non-enculturated apes, and actually showed that the apes with language training, but also a lot more testing familiarity, did much better than standard zoo-reared apes. So now I was going to look at that and try and say, oh, well, what do other primate species do? Went in, sat down with the bush babies, turned over 2 cups, hid a grape under one of them, and they were 50-50 picking where the grape was, even though they had just seen me put the grape under the cup. So I was like, all right, well, either they don't have object permanence at all, or something else is going on. So I decided to systematically test that, not just in bush babies, but in a range of primate species, and just to actually look at what do we see, not just with 2-cup spatial memory, but 3 cups and transposition and rotation, and what kind of stuff do we find. And a colleague of mine at the same time had said, well, you know what, I work with autistic kids, and I don't think a lot of the autistic kids will actually be able to do this task, partially because as you move the testing platform forward, there's a sort of sensory disruption, and that might be something that actually is changing the way the autistic kids are perceiving it. So right now we're running that. We're running the autistic kids, some neurotypical kids, and a range of primate species.
Oh,
so we did get bush babies all the way up till 3-cup. Like most of them would have passed the 2-cup eventually, but not to 3-cup. And now we're running mangabees and several different species of macaques, some lemurs, and the bonobos as well.
Are you looking at things like side bias, or?
Oh yeah, it's all counterbalanced. It's all like we're going to take a look at everything really, and we're also looking at. I mean, some of the primate species are a lot more, scent based than they are visually based. Bush babies certainly, who are nocturnal, have a lot more difficulty with visual tasks anyway. So we're going to take a look at all of that. That's probably going to be a relatively long-term project as well, to get enough examples in each section of the sort of primate strata.
Oh, that's great.
Can you put that into kind of a broader context then, this research?
Well, yeah, so the broader context for that is really looking... here's what it really is. I think that in cognitive research, there's been this amazing focus on the great apes, and the great apes are amazing, and they're fantastic, and they're certainly much easier to work with than other species because they're so much more like us. But with my interest in dolphins continuing, and I do have several dolphin projects going on as well, this idea of looking more broadly, comparatively, to get a better idea of the environmental pressures that create some of these cognitive abilities, or, it's entirely possible that they're actually just sort of physically important neurological rules, or, there's a lot of different reasons that we find analogous evolution, or even there might be that there's some sort of neural strata that is so basic that by the time you get to higher complex cognition, it all looks the same. And to try and look at that through primate species, but non-primate species as well.
It's really interesting.
Yeah.
So, how many primates do you have an idea of how many you want to have in this project?
Well, I'd like to get as many as I possibly can. Dwayne Rumbaugh did a task that was a very, very simple task, and his whole goal was to gather as many primates as he possibly could, and he ended up with over 500 primates in like 18 different species. So I don't think I'm going to go quite that far. I would love to get a couple hundred, actually, to get sort of 10 primate species or 20 primate species, even with 10 in each one. That would be amazing.
Well, for getting a lot of primate species, Inuyama is a good resource to get the highest density of primates in the world.
And diversity.
Yeah.
And diversity.
Yeah.
It's not just the PRI, we also have the monkey park next door, and they have a lot of primates.
There's, I think, over 80 species here.
Yeah, that's amazing. That would be great.
Yeah. Be cool.
So then will you go and link the ecologies of all of these species to your...
I would have to. I mean, the whole idea is to get enough so that we can actually do some of these more fine-grained studies and look at, well, does color vision, change? Does their diet change their ability? Does their, all that sort of... It makes more sense. I think we were mentioning at lunch even that any sort of fruit-eating primates would have more idea about spatial memory than any sort of insectivorous species, so that would explain why bush babies aren't particularly good at it.
Right.
Not just but also, just regular vision. They're nocturnal. They don't have color vision. They don't have really good vision. Period.
Actually, in the ecological side of this story, I mean, basically we're talking about the ability to form mental maps or spatial diffusion, basically, within the environments. And on the ecological side, there's a lot of modeling that goes into that, and there's a lot of things that are kind of known about, at least theoretically, the optimal ways animals are supposed to distribute themselves in their environment to search for food and things. And mental map being one of those, more often studied in primates, I suppose. But can you just give us the short version of how then your project scales up to that?
Oh, I don't know that it does. No, no, I don't know. My intention would simply to be to start listing off, both biological and ecological variables that we know about each of the species. The likelihood of me going deeply into ecology is not very high, but I would say that I obviously would want to bring in ecological variables because I think they're clearly going to be really important.
Sure, especially if you're talking about homologs in terms of evolution.
Exactly. Well, that's exactly right. And the other option is if we get some good variables that we think are strongly associated with this kind of spatial memory, is to create a computer model and run it and actually look at it from the evolutionary psychology perspective.
And are you just talking now about primates, or are you also talking about other species? Like, can you do like canines or dolphins?
I would love to do other species. The current plan is, dolphins I definitely have on the in the plan. I would love to do lots of other species. Actually, I have a proposal in at the Mobile Zoo to do some big cat work.
Oh, wow.
And because they have 7 tigers, and there's just nothing out there about big cat cognition of any kind. And the difficulty for us has actually been creating the apparatus that was going to allow us to work and to allow us to work safely, but allow them to actually do what they need to do.
That's right. I was going to ask you about that because now you have worked with a number of different species. You've got the dolphins, you've got the apes and things. So logistically, how has that been? And then can you compare and contrast them?
From great apes to dolphins?
Yeah,
in general, it actually is. Logistically, great apes are by far the easiest species to work with. Like, first of all, they have hands, they have thumbs, they have the same kind of vision processing that we have. We've worked out in zoos and whatnot how to interact with them safely in many, many ways. And I mean, just working with them through chain link is super easy, and all they have to do is touch something and we can give it. All primate species actually, have that ability.
And your apparatus typically involve these shelves that kind of roll back and forth.
It's like a tray table that is movable, and you just push it forward, and so you can manipulate things and then push it forward, and then they have the choice. And the idea had been to create this similar kind of apparatus for dolphins that would hook onto the side of the pools, and then you could manipulate, and then there would be some sort of signal that you would unlock them, and then they could, but you don't want them to have to point. So the idea is there's this question of whether they can declaratively indicate anything, even primate species, let alone big cats or dolphins. So you want some way for them to manipulate the cups themselves. And in this case, we were talking about actually tying a string to a cup, which would then tip over. And for dolphins, it's really easy. It just tips over far enough that a fish slides into the pool.
Okay.
For big cats, it was becoming much more problematic about how to get it through their chain link to them and without having a lot of rotting, spoiling meat somewhere.
Things to avoid, as you said it.
With,
the zoo guests might not be too appreciative of that.
Exactly.
Yeah, so one thing that we love here in Japan and at PRI is technology, like using touch panels and
absolutely
that kind of thing. Do you think that has any place in this type of,
I do,
especially with new species like the cats?
The cats. So a friend of mine at the Mobile Zoo actually has the bears, the black bears are touch screen trained.
Okay.
And the problem is that the one bear who uses his paw is very destructive. And it's so clumsy that to me it seems like it's just not the optimal use. So the rest of them are nose touchscreen users, which seems more likely. But with big cats, they have the big flat nose, so you don't really have as many options.
So are these bears all kept in the same enclosure?
Yeah.
Yeah.
But she actually has separate. So they have 3 rooms in the a shed, basically. So she can actually separate them out, and they're trained to separate out to come in and do her tasks.
It's really interesting, though. I was just thinking about this cultural transmission of behavior, social learning kind of thing. So how do you get the one bear that's a paw pusher, and then the rest of the bears are all...
That'd be amazing.
So
I have no idea if they do any sort of imitative social learning.
Is the paw pusher like a peripheral kind of individual that has no influence in the transmission of the behavior?
It's a darn good question. I don't know.
We're all excited now here about the Microsoft Kinect. It's this camera that you attach to your computer, and it can paint a 3D image of you.
Yes.
We can program for that. Great. They don't even need to touch the panel.
That's
they
right.
just orient it.
And that's actually my hope too. Eventually, we were looking at a system. It's not as cool as the Kinect system. Actually, the Kinect system is the next step up. But hoping to put together another Dolphin keyboard project that would then. Part of the problem with Dolphin keyboard projects is getting the information underwater, but also having some sort of interactive system where humans can use it at the same time as dolphins are using it, and humans don't have to be... Humans in the water is just super clumsy, and obviously dolphins outside of the water are impossible. So to get some sort of interactive system going through a window or something like that. And that was hopeful. The other thing that actually I've been looking at a lot is the use of iPads with the apes, and particularly the keyboard using apes, where a lot of people still go in with them, but or in fact to connect it to a wall. And the idea for me with that was one of the limitations with the keyboard systems, the computerized keyboard systems, was that when someone would come to the keyboard and enter in keys, you had no idea who that person was. So they did a lot of attempts to you have to put in your name, and then you have to, and that just takes away the spontaneity, and there's no communicative system going on there at all. So we had looked at actually with the iPad 2s came out with camera in them, that it would actually just snap photos or even take small video clips just at periods of time whenever an individual would start using it again.
Sure. Does it work out so well? You have to kind of go back at the data and look at a bunch of pictures, right?
That's right.
Who was using it at this moment?
That's right. And then you have to make sure that it's bright enough out that you can actually tell who it is, especially with bonobos. If you have this big black blob, it just doesn't work as well as one would hope. What works the best actually is that group in France that has the
with the IR chips.
They have the chips in there, and I was talking about that eventually, at least for the apes. But I was hoping actually to create this iPad system that then be used again with autistic children and with apes, and we could actually see language development stuff and compare the kids and the apes. That's very far in the future for me, but the kids could wear bracelets or have pins or whatever that would do the same kind of identification stuff.
That's quite cool. Wow.
Peace.
Sounds like a lot of interesting stuff in the
future. A lot of interesting stuff in the future. Let's hope I can get funding and access.
All right. Well, this has been a great podcast. I think we should wrap up.
Okay.
Thanks for joining us.
Absolutely.
And enjoy the rest of your time in Japan.
Yeah, will do.
All right.
Thanks.